Hi everyone, I wanted to do a quick video reminding you how to do systems of equations in 3 variables using your calculator. I know there's a video showing you how to do this in the notes for this week, but I did want to highlight it because it certainly will quicken the process for you while you work through these questions, which I know can be frustrating. First things first, you need to recognize that when you're doing this on the calculator, you're going to be doing something called matrices. And when you're doing matrices on the calculator, you need to be familiar with how to take things from equation form and put them into the calculator. And it needs to be in the proper notation. So first, you're going to be using a matrix, which is kind of like a big box. After that, you're going to have a row for every equation that you have. So we have currently 1, 2, 3 equations. So we're going to have 3 rows in our matrix. Next, we need to figure out how many columns we're going to have in our matrix. So we're going to have 4 columns, 1 for the x values, 1 for the y values, 1 for your z values, and 1 for what the equation is equal to. So there should be 4 columns to this particular matrix. Our x, our y, our z, and then let's just call that our number column. Okay, now that we know how to set this up, this would be considered a 3 by 4 matrix, 3 rows and 4 columns. Now that we know how to set it up, we're actually going to put the values in. So your calculator does not need you to input the x, the y, and the z in there. It simply wants the coefficients. So if you have a plain variable here, remember that means there's an invisible 1. So the coefficient for the first row, first column would be 1. Then in this one, our coefficient isn't just a 2, but also a negative. So take the sign with it. So then we'd have -2. The third one would be a 3, and it's positive. And the last one would be a 7. So notice how we're just taking the numbers. We're not writing any of the variables. For the second equation, we would have a +2 for our x. There's that invisible 1 again. So a +1 for our y. A +1 for our z. And a 4 for what it's equal to. Then in the third row, we would have our third equation, which would be a -3 for the x, a 2 for the y, a -2 for the z. Again, remember to take the sign with it, and a -10. So now that we have this matrix set up, we are going to input it into our calculator. Now, you've not learned, most likely, linear algebra, which is what matrices goes along with. So we're just going to use this pre-programmed program on your calculator to do the work for you. So once you know how to set it up in your calculator, we're going to use something called reduced row echelon form. So this is the particular program we're going to use on your calculator to help you with the math. So what we need to do is get our calculator and bring it over and go ahead and turn it on. And we're going to be using the matrix option. So if you look on your calculator, there is the second button and then this x to the -1 button. Notice above the x to the -1, written in blue, is the word matrix. So in order to get the matrix option of our calculator in play, you need to hit the blue second button first because matrix is written in blue, and then hit x to the -1, and it will bring up the matrices options in your calculator. Prior to doing any math with the matrix, we need to enter the information or matrix that we have here. So we actually need to edit what these matrices are. So go over to the right, and you're going to choose option A for number 1. So just go ahead and hit enter. And we're going to tell it the size of the matrix that we want. So again, it's row by column. And I explained that we have 3 equations, so 3 rows and 4 columns. So we're going to write a 3, enter, 4, enter. So that's telling us we have a 3 by 4. And just to double check yourself, you should see 3 rows there, and 1, 2, 3, and these little lines here are telling you that there's more on the right. So that would be our 4th column. Okay, so now we're just going to enter the numbers. So that numbers that we've already written down are what I'm going to input in my calculator. And when showing your work on your tests and quizzes for this unit, you should be showing me that you are doing matrices using RREF. So you could certainly write that down. You can write the size of your matrix down and show me what the matrix is that you input into your calculator. So let's input this information. So all you have to do is hit the number 1 for my first row, first column. So 1, enter, and it'll jump to the next value in the first row. So that's a -2. Remember, when putting negatives in your calculator, you have the negative sign. Do not use the minus sign. Your calculator does not distinguish between the two. So you need to, or it does distinguish between the two. You need to make sure that you put the negative sign. So -2, enter, 3, enter, 7, enter. And notice after 7, it jumps down to the next row. So then 2, enter, 1, enter, 1, enter, 4, enter. Again, negative sign, 3, enter, 2, enter, -2, enter, -10, enter. So now that I've entered this information into your calculator, you're going to go to Second, Quit, and it's going to bring you back to the home screen. Then we need to actually do the math with our calculator. So we're going to go back to matrix. So go second, x to the -1, which has the blue word matrix. We're going to do the math on it. So we're going to arrow over to the right to our second list of information. And we're going to choose RREF, which is reduced row echelon form. So I don't see it currently, but if I continue arrowing down, I see that option B, RREF, is what I want. So to select it, you hit enter. Notice that it has a parenthesis to start. That means that I need to tell the calculator some information. I need to tell the calculator which matrix to use to calculate the reduced row echelon form. So you're going to go back to second matrix, so x to the -1. And we're going to use the name of our matrix. So we're staying in this option, in this list of information. And we're going to choose option A because that is where I put the information for this particular matrix that we wrote. So we're going to have option A, and to select it, you can just hit enter. Close your parenthesis and hit enter. Now what you should see here is a 1, 0, 0, 2, 0, 1, 0, -1, 0, 0, 1, 1. So I'm going to take a moment and write that down. Now that I've written that information down, I need to recognize what it's telling me. So remember, the first column represents our x's. So what this is telling me is that if I have 1x plus 0 y's plus 0 z's, it's going to equal 2. What is 0 times x? 0 times x would be 0, so that would cancel out. What is 0 times z? Again, that would equal 0, so that would cancel out. So this is telling me that 1x, or in other words, x, is equal to 2. For the second row, we have 0x plus 1y plus 0z is equal to -1. 0 times x would cancel out. 0 times z would cancel out. And you're left with 1y, or just y, which is equal to -1. And I think you get the idea. So the last one, the last row, shows that there's 0 x's, there's 0 y's, so 0x, 0y, and there's only 1 z. So that 1 z, or just z, would equal 1. So this information that we have here, x is equal to 2, y is equal to -1, z is equal to 1, is the solution to this particular system of equations. Sometimes students will say that they're not sure what to do should an equation not have all 3 variables represented in all 3 of the equations. So as you can see here, we do have one equation with all 3 variables represented, 1x, 1y, and 1z. But in the second equation, we only have 2 variables, one y, and one z. And in the third equation, we only have one variable, one z. So you certainly can use matrices on your calculator, reduced row echelon form. This particular question I would expect to be able to be done by hand. But if you wanted to check yourself on the calculator just to make sure that you have it correct, you can certainly do so. If you wanted to put this into the calculator, you would still need 1, 2, 3 rows because there are 3 equations, and you would still need 3 columns because your longest equation, which is the top equation, has 4 pieces, an x, a y, a z, and what it's equal to. So you certainly would need the 3 by 4 again in this particular case, but you're just not going to have values for all of your x's and your y's and your z's. So the first one would be 1, 1, 1, 6. Your second equation, because we don't have an x, you would just have a 0x. So let me go ahead and write that in. You'd have a 0 for your x, and then a 1 for your y, a 1 for your z, and a 4 for your equals number. Same idea for the last one. You would have a 0x plus a 0y, and you would just put zeros in your calculator for those particular rows and columns that do not have a value for that particular variable. So then you'd have the 1 and the 3. So you could certainly do reduced row echelon form with this to check yourself. However, this type of question, I would expect you to be able to do this one by hand because it is much simpler and easier. You would just need to take your z value, plug it in, figure out what your y value is, take those two values to get your top equation. Now, sometimes, as you know, you will stumble across systems that do not have specific x, y, and z values. So this is when you have a no solution or an infinitely many solution option. So as we just saw, when you have a 1 for your x, a 1 for your y, and a 1 for your z spot in your answer, so again, this is our reduced row echelon form. This is what you would get back out of the calculator. If you have an x, you have a y, and you have a z in that particular spot, that would mean that we have 1x, which is equal to 1. We have 1y, which is equal to 5. And we have 1z, which is equal to 2. Again, you don't need to write those ones, so you can certainly take that part away. And so this one would have a solution. This is one particular solution. In the next example, here to our right, we have a 1 for our x, a 1 for our y, but something weird is happening in this last section here. This is telling me that 0z is equal to 2. So we have our x, our y, and our z. So it's saying that 1x is equal to 4, 1y is equal to 7, but it's telling me that 0z's are equal to 2. Well, we know that 0 times z is equal to 0 or nothing. So this is really telling me that 0 is equal to 2. And we know that 0 cannot equal 2. And so this would be an example of a no solution. Okay, this is also known as inconsistent. The last example I have for you is when you have your something for your x and your y, but the last row goes to 0. And this is going to be an example of an infinitely many. So our x, our y, our z. So it's telling me that 1x is equal to, it's telling me that 1 plus, 5z. Notice we have the z there, okay, that has a value, is equal to 2. We have 1y plus 3z is equal to 2, but it's telling me that 0z is equal to 0. 0 times z, we know, is equal to 0. So this is telling me that 0 is equal to 0, which is in fact true. So that is why this one is your infinitely many or dependent system. Now, in your textbook, they will often ask you to tell them what x and y equal in this particular situation. And when that happens, you're going to take each of these top two equations that you got here and solve for the corresponding x and y. So in the first one, I'll solve for x. I would subtract over x plus 5z is equal to 2. So I would subtract over the 5z, and I'd get x is equal to 2 minus 5z. And for the y, I would have y plus 3z is equal to 2. So I would subtract over the y, and I get that y is equal to 2 minus 3z. So hopefully that will help you with your MyLabs Plus. So when you're giving your answer for this one, it is going to be infinitely many. Your x value would be this new expression, this new equation here, 2 minus 5z, because you subtracted over the 5z and solved for x. And your y would be y is equal to 2 minus 3z, because you subtracted over your 3z. So this would be your x and your y values. Your z, of course, could be any number. So I'm going to go ahead and write that. Z equals any number. And that would be how you would write that for infinitely many. So sometimes it'll just ask what type it is. This would be infinitely many or a dependent system. And then sometimes if you get more specific answers, sometimes they ask for what the x and y expression would be. So it depends on what they're really looking for in that particular question. So that's what you should look for if you'd like to use the calculator to help you, that reduced row echelon form using the matrix on your calculator. Being able to put it into matrix form is really important, and then also being able to determine what your resulting matrix is. So again, if you decide to use your calculator for any of the upcoming assignments, please make sure to note that you're using the matrices reduced row echelon form on your work, as well as showing us what the input matrix would be, and then what the output matrix would be from your calculator. And then hopefully telling us as well what the x, y, and z values would be for that particular question. Last but not least, you should be getting used to creating equations for a given word problem. So I have an example word problem. I'm just going to roll through showing how to set up this particular word problem. Hopefully this will help give you a little bit of insight into creating those equations. And then once you have those equations written, you can either do the work by hand or using your calculator, whichever is easiest for you. So in this particular question, it says a manufacturer of furniture has 3 models of chairs, Anderson, Blake, and Colonial. The number of hours required for framing, upholstery, and finishing for each type of chair are given in the table. The company has 1,500 hours per week for framing, 2,100 hours for upholstery, and 850 hours for finishing. How many of each type of chair can be produced under these conditions? So the first thing you need to do when you're doing a word problem is really reinforce what your x, your y, and your z are going to equal in this given situation. And you do that by trying to figure out what your question is asking. So this question is asking how many of each type of chair can be produced. So x is going to represent the number of Anderson chairs, y is going to represent the number of Blake chairs, and z can represent the number of Colonial chairs. Now that I know what x, y, and z are, I need to come up with 3 equations to help us solve this. So the 3 situations that were given in this particular question are framing, upholstery, and finishing. So actually, let's make those 3 different colors to make it a little easier. So framing can be yellow, upholstery can be pink, and I'll make blue the finishing. Okay, so what we have here is places for each of those 3 equations that we need to write. One is going to be upholstery, one is going to be framing, and one is going to be finishing. So we need to try to come up with the equation for that. The table actually helps with organizing this in this particular situation. So if you ever are able to make a table, that might be something to think about. So Anderson chairs, remember, are X, Blake chairs are Y, and Colonial chairs are Z. So the framing equation is going to say, okay, well, for all of the framing that we have, 2 hours are spent per chair on Anderson, 3 hours are spent per chair on Blake, and 1 hour per chair is spent on Colonial. So that would be represented as 2 times X plus 2 times Y, or excuse me, 3 times Y, plus 1 times Z. And the total number of hours that the company can spend on framing, if you recall, is 1,500. So I'm going to set this equal to 1,500. For the upholstery, the company can spend 1 hour per chair on Anderson, 2 hours per chair on Blake, and 3 hours per chair on Colonial. So that whole per idea, not like a cat, but PER, you are going to write that as a multiplication. So that's actually the idea of multiplying. So we have 1 times X for our Anderson plus 2 times Y for the Blake plus 3 times Z for the Colonial. And if I look above, it says I can spend 2,100 hours for upholstery, and so that is what I'm going to set my equation equal to. And then last but not least, we have the finishing. So the finishing is 1 hour per chair on Anderson, 2 hours per chair for Blake, and a ½ hour per chair for Colonial. So I'm going to write 1 times X plus 2 times Y plus 1/2 times Z, and that would equal the amount of time that the company has to spend on finishing, which is 850 hours. So that's going to equal 850. So if you wanted to solve this by hand, you certainly could, using some of the ideas that you saw in the videos from this week. If you want to do this using reduced row echelon form on your calculator, you certainly could. Again, you would need to show us the input matrix and the resulting matrix, and make note that you used matrices using reduced row echelon form RREF on your calculator. So hopefully this lesson, although it is a little longer than I expected, can help you better work through the systems of equations for this particular section this week. Good luck!